Hi, and good evening, everyone. Thank you for being here today to celebrate the 50th anniversary of the Faculty of Engineering and Design. I am Rafiq Gubran, the Dean of the Faculty. We're joined today by multiple generations of Carleton students, Carleton faculty, each with their own memories of the campus and our own contributions to this university. So I hope you had a chance to reconnect with your friends and with your colleagues and with your professors at the departmental reception that took place before this dinner. And I'd like to thank the departments and the teams who organized this wonderful receptions in the departments. So to give you an overview of the evening ahead, we'll be welcomed in a few minutes by the university president, and then I'll invite you by table to head to the buffet. When everyone had dinner, we'll start our program and hear from a guest speaker from each department about how engineering made a difference to them and how their engineering discipline has shaped our society and where they were or where will we be in the next 50 years. We'll also see some familiar faces from our guests and friends that we probably haven't seen in a number of years. So to start our evening, please welcome Dr. Roseanne O'Reilly-Runty, President and Vice Chancellor of Carleton University. Thank you.
Good evening, everyone. You know, it's wonderful to be introduced by an engineer. The program is there, it's all in order, and it must be extraordinarily frustrating to have a president who was not an engineer and who's not going to follow the program. You know, this morning we recognized alumni, and we gave them pins to recognize the years that they graduate, and we welcomed them back to campus. And one of our alumni was not here yet, and he just flew in this evening. And Hassan Ahmed, would you like to come forward and get your pin? I'm deputizing. The other thing is the dean doesn't know it, but he's just been deputized to represent the alumni and award this pin. There you go. And on the way off the stage, you have to shake hands with the chancellor to make it official. He's over there. Let's give him a round of applause. Welcome. How many of you have been in this building before? Oh, most of you. Okay. Okay, but the ones in the back haven't, or else you can't hear. Or you can hear, but you haven't been here. Well, this is, we're calling it our river building, and we wanted to make it a very special building, and we moved the road. And the engineering faculty think that we moved the road just to prove that engineers can do anything. I thought the political scientists were a little bit closer to the truth when they thought we moved the road because we could do anything because the National Capital Commission didn't want us to move the road. But in reality, we moved the road because we wanted to be close to the river. We are close to the river, but the access was cut off by the road, and now you can just walk down to the water. And we wanted by our buildings to change the way the university is. We wanted to reach out and embrace the nature which surrounds us on two sides and the city on the other side. So as you see the campus grow, you'll see that no longer do the buildings look like the wagon trains circled, but they open their windows and look outside. And that is a wonderful engineering feat. It's also a feat of inspiration and showing what Carleton University can do when it takes on the world. And if you think about the three words that our alumni and our faculty and staff have been using to describe the university in our last strategic plan, they all refer to the Faculty of Engineering. I know the dean had a lot to do with writing the plan, but he didn't have a lot to do with writing my words. So the first part of the plan says that we are collaborative. And we work together, we work with others, we are a community, we are a family. And I welcome you all back as members of that community, as members of that family. And I want to tell you how much a family it is in engineering. One night, I was going to go home. It was about 7 o'clock, and 3 engineering students showed up in my office, and they said, "Could you please come and see the little robots that we made?" And actually, dinner sounded pretty good to me, but I thought, well, I'll go see those robots. They seemed very proud of themselves. And I went to see their robots, and in the room, there were 25 engineering students and 10 of the engineering faculty, all of whom had stayed. And the students demonstrated what they had done, and the faculty were so kind and so gentle to those students, telling them what they did right and how it could be better, that I was really proud, because they were really good teachers. They really cared about the students, and they made it possible for them to learn both inside and outside the classroom. So that is collaboration. The next thing is leadership. And this faculty is on fire. It's leading. It's winning contests around the world. Engineering students went to Toronto, and there was this idea contest, and they won first prize, and the audience applauded, and then they won second prize. Go ahead, you can applaud. and then you know what happened? They won third prize, and all the other universities started tearing out their hair. So Carleton students are really great, and the engineering students are winning awards around the world. They are so good that they made the dean demonstrate his leadership. I know the dean says he probably doesn't want you all to know this, but he always says to his students, his graduate students, if you submit a paper to a conference, I will pay for your travel out of my own pocket. This year, he paid for all his students' travel, and he didn't have any more money. And one of his undergraduate students came in and said, I'd like to submit a paper too. And he said, go ahead. And the student's paper was accepted, and he paid for that one too. So I think we have a wonderful leader in our dean and in our faculty. And the last word is resilience. And resilience for an engineer is probably the material that is around the airplane or whatever fabric we need that will be both strong and bend. But it also is a human characteristic of Carleton University. It's a university that has sometimes had a few hard times and has always come back. And I think we need leaders in the future who know how to take hard times and turn them into good times. And tonight, when I see you here, I know it is a good time. It is a splendid time to see so many engineers celebrating 50 years of success. I think we all should say happy birthday to each other and shake the hand of the person next to you. Go ahead, it's okay. It's really corny, but go ahead. Yeah. We were going to have a cake with candles, but since you're all engineers, we know that you could do something a lot more high-tech. So you have to come back next year and see what we do for 51. Welcome back. I hope you have a wonderful evening, and thank you very much.
So I hope you're enjoying the dinner. So let me tell you a few things about the faculty. So as you know, the Faculty of Engineering and Design celebrates today 50 years of excellence and achievement. And we've long been innovators and trailblazers, and we continue to drive forward solutions and technological innovations that will shape the future and make the world a better place to be. Although we're celebrating the 50th anniversary, but we have a graduate here who graduated because we started as a very small school, and then we became bigger. So in fact, the school started even before that. So with us today is Catterall, who's graduated here from engineering in 1961. So welcome to Don back. Welcome to Ron back. So when I say Faculty of Engineering and Design, I mean everyone in this room, our researchers, teachers, leaders, students, alumni, all are part of our community. And we are driving the organization that shapes our society and challenges up the various things we're doing and challenging our society and creating new solutions and new innovations. Throughout our history, pioneering initiatives, including, for example, the first program in aerospace engineering, the first program in communications engineering in the whole nation, were put by Carleton researchers at the leading edge of emerging industry and ahead of the curve in scientific thoughts. And we have never stopped innovating. So the number of programs we have and the quality of program we have are second to none. So in partnership with government and industry, we focus on education and research opportunity that emerge and anticipate the changes that are needed by the society. And it's not just at the undergraduate level, at the undergraduate level, at the graduate level, at the research level. So we're trying to be ahead of the pack when it comes to all of those activities. So as demand for environmentally friendly options, for example, comes up, we had environmental engineering, we're looking at security and reliable infrastructure, we're looking at fast analysis of big data. When the needs for those new disciplines is coming up, Carleton expertise in sustainable energy, in infrastructure resilience, and in data analytics in the Faculty of Engineering and Design here continue to push research forward and start new initiatives, be it undergraduate programs, graduate programs, and research initiatives. So we tackle the increasing demand for renewable energy, for example, finding out solutions for clean air and water, finding out more efficient approaches for transportation. We make breakthrough in healthcare through efficient and affordable diagnostic and therapeutic techniques. So as you know, we have a number of programs dealing with health, including, for example, biomedical and electrical engineering that deals with medical instrumentation, medical imaging, remote patient monitoring, and medical informatics. We also have biomedical mechanical that deals with prosthetics, artificial tissues, artificial organs. So we've started many, many programs in the past few years in the area of health, as well as in the area of sustainable energy. And the last program we've started a couple of years ago is a new Bachelor of Engineering in Architectural Conservation and Sustainability. Our graduates are the best proof of our success. So you are here, one of the proofs of our success. So as leaders, innovators, global thinkers, productive and creative citizens, we've made a difference in the world. So tonight we'll hear from 4 of our graduates, and a number of professors are going to help introduce them. So to introduce the first speaker, I'll ask Professor Dick Kind from our Department of Mechanical and Aerospace Engineering to come to the podium to introduce our first speaker.
Well, thanks very much for those remarks, Rafiq. I'd just like to echo one thought that you put out, namely that Carleton Engineering is second to none. As it happens, I have an opportunity to see all the other engineering programs in this country, and I very much reiterate that thought. We are second to none. We may not have the age of some of the places with higher reputations, but we're at least as good. Anyhow, I'm Dick Kind, a retired prof from the Department of Mechanical and Aerospace Engineering, and quite a number of years ago, I had the very good fortune and pleasure of serving as Hassan Ahmed's thesis supervisor, and he reminded me, I'd forgotten this, I'd also served as his advisor for his undergraduate final year project. Now, those of you who've had an opportunity to scan his biography may have noticed that Hassan did his undergraduate degree in electrical engineering, his master's degree in aeronautical engineering. That's how I got that privilege. He was a brilliant student. I think he's still brilliant. You may think he was a bit nerdy, but really quite the contrary. Anytime you saw Hassan, he had a little bunch of other students, admirers around him, and it was very clear that he was interesting to be with and fun. I guess in today's words, he was cool. And I would venture to say, to the extent that young people today would allow that, he's still cool. But more to the point, he's very much a mover and shaker. He's done all sorts of things in his career, including being a prof for a time, but he's been the founder of companies. He's been heavily involved with innovation and making jobs for the rest of the world. Currently, he's chairman and CEO of the firm Networks, and they're developing disruptive technology, if you like, technology that will leapfrog existing ways of doing things, technology for operation of wireless networks. So probably in very few years, when you use your smartphone or whatever, it may very well be operated using products from a firm Networks. Your Rogers or whoever will be beating a path to the door, I think, in not too many years. Anyhow, with that, I'd like you to welcome Hassan Ahmed.
Wow, well, thank you, Professor Kind. I haven't come across anybody, most notably my kids, who think I'm cool, so I appreciate that you do. It's really great, actually, to be back at Carleton, and maybe if you'd indulge me for 1 second before I talk about electrical engineering, maybe I could talk, if you don't mind, share a personal experience that's related to the entire faculty here at Carleton. When I first arrived at Carleton, I was 15 years old, and I wanted to do just one thing, and I wanted to be an electrical engineer. And Carleton in those days had a 3-year Common Core program, and so it was actually, a real annoyance that, hey, why do I have to take strength of materials and fluid mechanics and things like that? And I have to say that I would learn very quickly just how narrow my viewpoint was, and I have to say I thoroughly enjoyed every course I took here. It's what led me into aeronautics with Professor Kind, and I'd say that in a lot of ways this working on cross-disciplinary activities has served me very well in my career. So the gift, I suppose, of opening my perspective and opening my mind is something that I'm eternally grateful to the Faculty of Engineering for. So I appreciate that very much, and thank you all. It's a nice opportunity to thank you tonight. Well, turning to electrical engineering, I'm maybe one of the ones who's been around for a while, 35 years. So life has changed a lot. When I first started at Carleton, double E in computer science were really the same department. TVs still had vacuum tubes in them. The microprocessor had just recently been invented. And, the notion of GPS, it was still a concept. It was undergoing feasibility studies, actually one of my summer jobs that I had. And people communicated by writing letters. And, Gordon Moore was just fashioning this notion of Moore's Law, which would underlie really the revolution in electronics that actually still continues. And our faculty here were actually busy creating courses to get us all on the leading edge. Archie Bullen did all the microprocessor courses and a whole bunch of others that, that created leading edge courses, and our fellow students were all trying to consume them. So fast forward today, with this progress in Moore's Law, computing is about 1 million times more capable and about 1 million times cheaper than it was back then. So as a result of that, for those of you all carrying smartphones in your pockets, like the iPhones, it has about the same amount of power as the Sigma 9 that used to power the entire campus back when I was a student here. If you sort of think about what it's capable of letting you do, and you have it in your pocket, it tells me where I am, it tells me where I'm going. GPS is a reality. I can communicate instantly with anyone around the world. I actually have, thanks to folks like Google, the knowledge of the world at my fingertips. And that's a really major change compared to what it was like when I started here in engineering. I remember as a child, when we traveled overseas, my father would then, once we arrived, would go find a telegraph office and send a telegram to my grandparents telling them that we had arrived safely. So today when my kids travel, I get a text message that says landed. And that's for me, but for their more tech-savvy friends, they just update their Facebook status. And all of this happens before the airplane is actually taxied to the gate. So, I think the face of communications is very different. Grandparents don't receive aerograms anymore. They can actually Skype with their grandkids and be really involved in their lives as time goes on. So our lives are, definitely much more connected and much more flexible because of electronics, because of this doubling of capacity over 18 months that Moore's Law embodies. And this revolution is about 40 years old. It doesn't show any signs of slowing down, so it's going to be a factor with us going forward here. But I would submit to you that the next set of 50-year revolutions are really going to be on interdisciplinary boundaries. I don't know how many of you saw or perhaps remember the story from last year where there were a couple of researchers who were struggling with the question of how to store the volume of data that their research in the human genome was creating. And even with Moore's Law and even with the halving of storage prices every 18 months or so, it was still just way too much data. And so they devised this very clever technique for storing their information on strands of DNA. And in fact, just to demonstrate it, they took all of William Shakespeare's work plus Martin Luther King's I Have a Dream speech and embodied it or stored it on a strand of DNA, which is obviously not visible to the naked eye. So, we think about the electronics revolution as having driven a doubling every 18 months. Well, this thing kind of moves the bar by a factor of 100,000. So I think that when we think about the next set of revolutions, as it were, I don't know what they're going to be, but I do know that in order to take advantage of techniques in synthetic biology and so forth, our engineers are going to have to be trained in a lot of different disciplines. And I'm confident that the Faculty of Engineering here in Electrical Engineering faculty at Carleton will be devising the courses to educate the next generation to embark on these revolutions, much in the way that my professors did when they prepared me for the computing revolution. So thank you, faculty, for everything that you've done for us.
My name is Patrick Salvador. I was a faculty member here a long time ago. And it's when Paul sent me this email that there was a 50-year gathering here, and I was in Europe somewhere. I said straight away, I'm going to come to the event because Carlton has a special place for me. It started off as my academic career here, so I think it's the right thing to do is to come and support it. It's a pleasure for me to introduce the speaker, Gina Courtland, but I think I knew her as Gina Athanasiadis. She used to be a student in our department, and one thing that struck me about her is really she was always a bubbly student, always very excited and interested in academic affairs as well as social affairs as well. She used to always be in the front row of my class, and I won't say anything more. Gina has been with the construction industry for the last 24 years, and she's now the Vice President of Lundy Construction. And she has made a career of being in the delivery end of civil engineering, and has been involved in very prestigious projects, including the Humane Society, Ottawa Construction, Rideau Conservation Authority, Algonquin College, and the Ottawa Senators Hockey Arena, to name quite a few. The year of Gina's graduation is a special one for the Faculty of Engineering as well. It's 1989, and that's the year that Civil Engineering Department and Mechanical Engineering Department hosted the Canadian Congress of Applied Mechanics, which was a great success. And so without further ado, I would like to invite Gina to say a few words.
Well, hello, good evening. I first want to thank the Department of Civil Engineering for inviting me to come here and speak to you all tonight. And also a great thanks to Professor Patrick Salvador, specifically for helping me to try to understand the behavior of what lies beneath our feet. It's not something that I can really explain to you, but geotechnical engineering wasn't one of my fortes when I was at school. But just because I cannot see it doesn't mean that I need to be afraid of it, and that's something that Patrick did teach me then, and it's a lesson that I've carried through with me throughout my career, together with the fact that I know nothing, I will always know nothing, and I'm always learning. When I was considering my postgraduate studies, my post-secondary graduate studies, I really had no idea what I wanted to do. I have to thank my father for making that decision for me. At the age of 12, he said, "You're going to be an engineer." And I said, "Oh, okay." I was a good daughter, so I really didn't question the reason why I was going to become an engineer. And it wasn't until puberty hit and the hormones that I decided Dad really didn't know very much of anything that I started to question things. But I really didn't fight very hard. When I applied for my engineering studies, I was accepted in electrical engineering, and that's how I started my studies here at Carleton University. But after 2 years of Common Core, I knew that electrical engineering was just not meant for me. I couldn't see it, and I couldn't touch it, and as a result, I couldn't understand the significance of it. No offense at all. So my father, an electrical engineer himself, was hugely frustrated and mortified when I said to him, "I'm going to switch to civil engineering." "All they do is look up beam sizes in tables, Gina. Why would you want to do that?" was his answer to me. And thank goodness that by then I had learned to make my own decisions. On a whole, the whole environment, both the man-made and the natural that we live in, and the relationship between the two is what the focus of the civil engineer is. What an extraordinary opportunity it is for us to be involved with the design, the construction, and the maintenance of something that has been with us for millennia and is essential to our existence. We're not just talking about roads and bridges and dams and buildings. We're talking about how we deal with food and water supply, electricity, how we live, where we work, and how we use our natural resources. This is how I think of civil engineering. Things that we take for granted and that are provided to us either from the public sector or the private sector. And it seems that without them, we just could not exist. From the beginning of recorded time, we have been designing and building things. The reasons vary, and it could have been for survival at the beginning, for power, for legacy, for progress, or for profit. But for whatever the reason, it's in our nature. It's in our nature to have a vision of what could be, to take a practical need and somehow a whimsical need maybe, and create something around it, to take a problem or a challenge and find a solution for it, a workaround. Until modern times, there was really no clear distinction between architecture and engineering. Until the 18th century, we were known as the master builders. So for the most part, we were artisans, we were carpenters, we were masons, and we were responsible for designing and for building. And we used tried and true methods, and we used an infrastructure that already existed and was repetitive in nature. The advances were incremental at the time, and the increases in scale were really quite limited. And it wasn't until the 18th century that the term civil engineer really was used independently from any other term. The 19th century saw the development of the first separate disciplines for civil engineering in private colleges. And by the 20th century, civil engineering and institutions and societies had really flourished throughout the world. And now, although architects and civil engineers have become really clearly distinct, We both have very definite works that we do, but we can't work alone and without the help of one another. So recently I read in an engineering journal this explanation of the difference between architecture and the civil engineer, and I'll just read it for you. A little bit paraphrased, because my husband's an architect over there, and he really had something to say about it. But architecture is the art and science of designing and constructing functionally graceful structures to serve the user well and satisfy varying and complex needs. Civil engineering is the brilliant planning and execution of the dream passing through a ton of barriers to make it a reality. So the most modern concepts of civil engineering have also evolved. The use of physics and mathematics and other sciences have contributed. We've explored the possibilities of materials and methods, and we've opened up doors for some really incredible feats of engineering today. What was impossible to consider only 50 years ago has now become almost routine with the help of computers and other high-tech machinery. Computer-aided design has allowed us to achieve efficient systems for construction as well as for manufacturing and for fabrication. Three-dimensional design is today an essential tool for the design of complicated structures and the carving and making of objects, which is a fascinating thing. So we are now entering into an era of holographic imaging that really was only thought possible in the movies. So where does our future hold? Again, I can't really answer that question. Solving world hunger, world peace, space, the final frontier. Whatever it is, it will rely on one thing, though, and that's our imaginations and our inherent need to create and improve what we do and how we do it. So thank you very much.
Good evening, ladies and gentlemen. My name is Herb Saravana Mucho. I am also a retired professor from Carleton University. I came here in 1970, and that seems like quite a long time ago now. I actually retired 15 years ago, not terribly successfully. Perhaps one thing I should mention, totally nothing to do with our department, is that one of the people we have here who's not been introduced at all was Carleton's first PhD in engineering, Dave Call. Right? I was attracted to Carleton University because Doug Miller was building up a group in gas turbine engineering. He hired a number of people from various companies around the world. And I came from Bristol to work with that group, which has been quite successful over the years. And quite a lot of our students have gone into the gas turbine world, both operationally, design, forming new companies. And we have in Ottawa a company that's been very, very successful on a world scale in building advanced test facilities for gas turbines, literally all around the world. And that is a company called MDS Aero Support. And we have quite a number of students from Carleton who started off there. They have been very strong supporters of our co-op program, and in fact, MDS Aero Support was the Carleton Co-op Company of the Year last year, which we congratulate them for. But John Jastrzemski was a very good student in the 90s, and he did a master's degree with Joe Wong, and then he went to MDS about late 90s, and he has now become the Vice President of Business Development and is very much involved in the promotion of their work around the world. So without further ado, I call on John Jastrzemski.
Thank you very much, Professor Saravana Mucho. It's an honor, it's a real privilege to be invited to speak with you this evening. The collective brain power in this room is pretty overwhelming, and actually when I was asked to speak, at first I thought they had made a mistake because though certainly very passionate about engineering, I'm very focused on trying to sell technology to different customers around the world. And though I have an undergraduate and a master's in engineering, certainly felt through my whole studies that everyone around me was significantly smarter than I was, and just that collective brain power was rubbing off on me, and somehow I managed to sneak through. As a graduate, and having hired dozens, or at least a dozen myself, and dozens with the company of Carleton graduates from the mechanical engineering department, and having seen them excel on the world stage in terms of aviation and energy sectors, certainly you should be extremely proud of the accomplishments and the great institution that you've developed here over the last 50 years. Mechanical engineers are concerned with the principles of force, energy, and motion. And mechanical engineering plays a dominant role in enhancing the safety, economic viability, and quality of life through developments of automobiles to airplanes, refrigeration to numerically controlled machines, high-performance materials to codes and standards. I mean, the list goes on. And basically every aspect of life is touched by mechanical engineering. At MDS, we design and supply certification and development facilities to support the aviation, industrial, marine gas turbine engine industry. When my 9-year-old daughter asks me what we do, I simplify it and say we design technology that helps make airplane engines quieter, cleaner, and safer. And over the decades, MDS has supported the development of nearly every major aviation engine on today's leading aircraft. And when I sit back and think of what we've accomplished as a company with such a small number of people, I'm very amazed. And it just goes to show you what you can accomplish if you get a bunch of smart people together and give them problems to solve. Where is mechanical engineering heading? In our world, we see real growth in modeling, simulation, virtual prototyping, energy storage, and energy recovery. But to echo some of the comments made earlier, and Hussein hit the nail on the head from my perspective, I also believe the best engineers of the future will be those that excel in cross-disciplinary knowledge. For example, engineers that understand material science, but also understand how the processes associated with those materials, to me, are going to be the engineers of the future. Though continual development in new technologies is critical to the growth in engineering, I believe broadening the appeal of engineering plays just an important role. And let me share a personal experience with you. As a global technology-based organization dealing with market leaders in aerospace and energy sectors, something that I recognize very clearly today with these leading firms is how technology, or how technical each of our touch points are across their entire organizations. This means not just engineering, but procurement, management, marketing, sales, business development, and even finance. What I didn't recognize, or what I didn't notice early on in our organization, was that many of our staff not engaged in direct engineering activities had non-technical backgrounds. Just over 10 years ago, I was asked to lead the sales and marketing team at MDS, a successful engineering firm with a 20-year track record. And as an engineer with a master's, I thought management had completely lost their minds. After being asked again, I started to give it some thought, and that's when I started to think about our organization and our entire industry in a completely different light. Why did I have the ability to connect with customers, Why could I understand their issues, and how was I able to gain their trust? And what it boiled down to was that we could speak a common language, and that common language was all based on a strong technical foundation. And from that point, it was dead simple and obvious. I accepted the role and immediately started to surround myself with engineers, much smarter than I was, but those that had developed or had a natural ability for communication, social awareness, and basic business skills. And literally the rest is history. The results were drastic, and we followed a similar strategy with other parts of our business, and we've never looked back. I believe the reality with technology-driven industries to create, to sell, to produce, and to manage technologies effectively, you really need to understand them. In my view, Canadian industry will only succeed by leading in technology. Let's face it, we're never going to win on cost, and that's pretty clear. But how do we get people excited about technology streams like mechanical engineering? And how do we raise the bar on the development of other complementary critical professional skills? So based on my limited experience, we need to appeal to a wider group of candidates by better defining the potential opportunities a technical or engineering background offers. I had the pleasure of being invited to participate on a review board for the case study program at the Sprott School of Business here at Carleton. This course is an example of an outstanding backdrop for the development of professional skills such as communication, presentation, preparation, basic business, all of which we look for in our hires. And at MDS, those that excel in their roles have both of these areas covered. And from my perspective, we need more people with this combination of skills. Based on the rate of change of technology, I would struggle to even forecast the next 5 years, let alone 50. But I truly believe that we haven't even begun to understand the possibilities and the futures that exist within mechanical engineering. And something that Professor Saravana and Mucho and I were talking about earlier, and I just want to mention because I think it's such a key point. The co-op program at Carleton, certainly we're big believers, and we take 4 to 8 students a year. And though we use some pretty rigorous screening techniques, we rehire virtually every one of those students. And when those students come back to school, they have a renewed enthusiasm because they've bridged that gap between theory and practical understanding. And when they come back to work for us, they're miles ahead of the competition. And that provides us with a big edge. And one of the incentives that we use, and some of these students think we're crazy, but it's a great deal for us. After third year, they spend 18 months with us. We pay their 4th year tuition. We give them some spending money, and we ask them to make a commitment to come back and work for us. They can't quite understand it because it doesn't make sense to them, but it makes a lot of sense for us. And what we find is that they approach their final year with a completely different perspective. And what I've noticed as part of my international travels is that this industrial experience program is picking up steam all around the globe. In fact, in some countries, it's even being legislated because they recognize the value that a program like that brings. So Carleton's ahead of the game in some regards because of the strength of your program, and I really feel this is a future. At the end of the day, we want to build a reputation for providing a great education, but we also we have got a great opportunity through that program to really ensure that our people are getting jobs and getting work in strong technology sectors. So thank you very much. Appreciate your time. It was a real privilege. Thank you.
Good evening, everyone. Welcome back to the campus. Those of you who I recognize from long ago. My name's Dave Call, and I'd like to thank John for his remarks. A lot of challenges there from a very practical point of view from successful industrial. Anyway, my background at Carleton goes way, way, way back. I was sort of here before the buildings were, not really, but there was one. And I started teaching as a sessional lecturer while I was still working for the Defense Research Board. And that's engineering occupied, I think, maybe a maximum of about 3 rooms on the top floor of the Tory building. My, how it's grown. And in 1966, I received the first PhD awarded by Carleton, and I soon joined the faculty full-time, I think that fall. And so I served as chair of the Department of Systems and Computer Engineering at two different times, one of them filling in for a year. But now I'm happily retired as a professor emeritus, so I can sit back and enjoy my retirement. So it's my distinct pleasure this evening to introduce Charles Chi, the new Chancellor of Carleton University, new to us who haven't met him before, although he's been Chancellor for a while, so he's been off in Silicon Valley practicing, I guess. So he's a computer systems engineering graduate. He claims to have successfully completed my course in linear systems, and he went digital on us, yes. So did we all. And at that time, Carleton's program, as you just heard previously, was based on broad coverage of the fundamentals in electrical, mechanical, and civil engineering. Now I was almost unable to count the number of degrees that the faculty offers. And so it meant that every Carleton graduate at that time was almost 2 other brands of engineer. And in the year, let's see. Yeah. But anyway, since his graduation, Charles has established himself as a successful entrepreneur, innovator, and investor in technology on a global scale. A truly remarkable record. And I'd like to think, perhaps, he might confirm it or deny it, that the ability to understand the potential of new technologies and the market for those technologies that has guided his career is based in no small part on the breadth and depth of his Carleton education. But I'm sure that the knowledge and experience that he has gathered in Silicon Valley will be put to good use here in the Ottawa Valley to the benefit of our university. And now I'd like you to please welcome the Chancellor of Carleton University, Charles Chi.
Thank you, Dr. Cole, for those very fine words. Students, alumni, faculty, friends, and family, I'm delighted to be participating in this celebration of Carleton's Faculty of Engineering. It is wonderful to be here and more enjoyable each time I come back to Carleton. But then again, I have graduated. Truly, though, to see old friends make new friends, being able to admire the progress at Carleton is making us very much gratifying, and I'm thankful to be playing a part of it, even in my own small way. Tonight, I've been asked to speak about how my engineering discipline, systems and computer engineering, has evolved and where it will go. That is a really, really big topic, which I will touch on, but permit me some poetic license to let this conversation meander a little bit. We all know what computer and communications has done for our lives. Looking back to when I graduated and first started work and how business was done back then, mobile phones were rare, as were laptop computers. Presentations were made by photocopying text onto transparencies. Sounds utterly primitive. Of course, today, we can multitask, multimedia on our smartphone, let alone on our computer, connect directly, immediately, in many different ways to whomever we need. We can broadcast to the world everything from political outrage to what we just had for dinner. And then maybe we can rent a spare room to a stranger, directly to the buyer, publish and sell a song that we just created, or maybe a short story, or fulfill an order for a product we are distributing in our spare time. These, to me, represent some very powerful themes. One, massive increases in productivity, both in industry and personally, and individually. Two, disaggregation of entire industry sectors. Three, personal empowerment and enablement. And four, the consumer is simultaneously both the consumer and the producer of products and services. Clearly, the impacts are not simply technological. They have far-reaching sociological implications as well. Whether one is on the receiving end of massive industry dislocation or alternatively tremendous wealth creation really depends on how one embraces and capitalizes on the march of technology. And we should expect this to continue, maybe not in the leaps and bounds that we've seen, but relentless no less. The constant is change, as the cliche goes. It is our experience, our actions, and our education that prepares us. Dr. Cole, you made a comment 27 years ago regarding linear systems that has always stuck with me. This course helps you explain how the world works. You know, that comment touches on the enduring value here. Carleton's engineering education gives us a framework for creating solutions to problems previously unencountered. When coupled with one's own imagination, it will help you see around corners, to be ahead of the industry dislocation, or better yet, be the instigator of dislocation. While the most direct impact of my engineering education at Carleton was getting my first job after graduating, that in itself was worth the price of admission, I can't help but see how its influence has been enduring in other roles, from marketing to starting a company to sales to venture capital. Over a period of 10 years in venture capital, I must have looked at least 1,000 companies. Each one had an idea to create something in the future. Forecasting the future, let alone investing either money, capital, one's time, in a result that is years away is very, very difficult. To be better than a roll of the dice requires, at the very least, a frame of reference from which to extrapolate the possibilities. In the technology-centric world of startups, that is typified by the hyper-frenetic pace of change, for me, it was an engineering background from Carleton that provided that foundation. Even in my post-career, call it permanent sabbatical, also known as retirement, the value of my engineering education persists. Earlier this year, my wife and I purchased a ranch property to do something I've never done before, create a farm. One of our secret projects is we are going to cultivate truffles. You know, mushrooms that cost $3,000 a kilo. So for phase one, we're planting 600 trees whose roots have been inoculated with truffle spores. The problem is there's no successful precedent for cultivation of truffles. It takes over 7 years before your first harvest. The truffles themselves grow underground, so you can't see your progress, let alone measure it. And to make matters worse, you need a pig to find them. So I met with an irrigation expert, and I provided him with the high-level parameters for the truffles irrigation needs. Of course, as a former engineer, or perhaps a repressed engineer, I did my own calcs. Given an average volume per day, this much PSI for the sprayer coverage, include some head loss, add a couple other parameters, carry the one. I came up with system sizing for the pumps, water storage, pipes, and everything else. To my surprise, the irrigation expert came up with something that was literally 10 times the size. My first thought was, I wish I had taken fluid dynamics. But because I had some kind of initial calculation, because I had gone through the mechanics of the system, the expert and I could have a meaningful discussion. And the source of the differences between our points of view could be understood. And as it turns out, I was right. Let me get back to you, though, in 7 years, whether this is going to be a successful venture or just an expensive forest. So to close, as we pursue our interests, whether it be career, family, or personal, I have found that in the moment and in the long run, doses of thoughtfulness, humility, and humor, sprinkled with engineering, can make a big difference in the outcome. I have Carlton U to thank as one of my sources for that perspective. Thank you.
Thank you, Charles. And thanks to all of our speakers for your inspiring talks, for sharing your views with us, for sharing your memories, and for talking to us about your vision about the various disciplines. So thank you very much all. And I fully agree with the speakers that the future definitely will have lots of interdisciplinary aspect to it. So all of the new disciplines that we've introduced recently and all of the new disciplines that are now emerging includes interdisciplinary activities within engineering and between engineering and other disciplines as well. So for example, our new program in sustainable energy is sustainable energy engineering and policy. Because again, engineering alone can solve a problem, but unless you have the policy and regulations that allows you to implement those, it's not gonna work, and vice versa. So I fully agree with you, and we'd like your feedback on a regular basis to see where we're going, and we need your help to make sure that our vision is in the right direction. So there's no question that engineering is a dynamic profession with evolving disciplines. We've got big challenges ahead of us, but I'm confident that at Carleton and in the organizations in which our graduates work and with our research partnerships, we have the innovation and determination to find solution and to make the world a better place. So thank you all for coming. I hope you're as proud as I am of the achievements of our colleagues, former classmates, students, researchers, and the next generation of engineers that we're educating right now. So thank you very much for coming, and please enjoy the rest of the evening. And I understand there will be desserts, right? The back. So please enjoy the evening and take the opportunity to chat with each other. So thank you very much again, everyone.